Certify ready to resume count and go for launch. Say go, no go. OTC.
Go.
TBC.
Tank and boosters are go.
PTC.
PTC is go.
LPS.
Go.
Milo.
Milo's go.
SPM.
SPM go.
Safety console.
Safety console go.
SPE.
SPE is go.
LRD. Land and recovery are go. And SRO.
SRO is go. You have a range clear to launch.
I copy. And CDR.
CDR, the Discovery crew reports go for launch.
Copy that. And launch director NCD, the launch team is ready to proceed.
We launched on June 8th into space, and as soon as we launched, due to aerodynamic loading, I mean, you're basically going from 0 miles an hour sitting on the launch pad to 17,500 miles in about 8.5 minutes. So things are happening very fast. As you're going up in the atmosphere, you're fighting all the aerodynamic forces that are trying to keep you, on the ground. And it's during this ascent that the wind basically took part of the thermal protection system on the space shuttle and pulled it back. And we actually didn't figure it out until we got on orbit. Opened up the payload bay doors of the space shuttle and looked outside the back, and sure enough, there it was, a hole in the thermal protection system. Now what does that mean? Well, it was a hole in the thermal protection system that brought down Columbia. So the first thing we did is we started taking pictures. Didn't know what we were going to do. We didn't have a repair on board at the time. All the thermal protection engineers down on the ground were trying to figure out exactly what needed to be done. So material science is obviously a very important thing when it comes to thermal protection system. The solution, surprisingly different. As the astronauts were trying to figure out how am I going to, once they give me the instructions, how am I going to stitch this thing in place on orbit, which by the way, you're in a spacesuit, and if you have a needle, you don't want to put a needle anywhere near a spacesuit because it's just a giant balloon. But in the back of the room was the flight surgeon, Jim Locke, our flight doc. And he's watching the engineers kind of flail about there. He raised his hand and said, "Hey, could you guys use a stapler?" And the engineers said, "We don't have a stapler on board." And Jim said, "Yeah, you do. It's in the med kit." As it turns out, astronauts have to be trained how to become crew medical officers, because if you get into medical trouble in space, you can't just go down to Kaiser and get yourself fixed up. You gotta figure it out on your own. And so there's a little med kit that's on space station, like a little first aid box. And inside that box is a set of little staplers. So in case you bonk your head and get this pretty good lash on your head, you can actually take that stapler and staple it back shut, because you don't have to have suture it. But Jim said, "Hey, we've got this stapler and it's got stainless steel staples in there. Do you think that those would work?" The flight engineer said, "Let's give it a shot." They tried it. Brilliant solution. Simple, very, very, very clean. Very easy to do. It still took me 3 hours to do the repair, so luckily I was on the clock. Our primary job on that particular mission was actually to take a large piece of the truss segment of the space station. And the space station, tip to tip is about a football field in length. On that mission, we had to take one piece out and actually hang it on the end and set up a new set of solar arrays. And the solar arrays weren't there before. We had to pull some solar arrays out and get them deployed. And the reason is because this was part of an assembly sequence. It's part of a construction job. Had we not been able to complete those mission objectives, the subsequent task could not have been performed. So we had a thing that we had to go do. Focused on that, we went out there and we hung these solar arrays on the end. Well, surprisingly, as soon as we attached it to the space station, next thing you know, the computer systems on the Russian segment, three sets of computers, all failed. They were the ones that actually sent the commands to the boosters to allow the space station to hold its attitude. So now we had another problem that we were faced with. So the first thing we did, we worked with our ground controllers on the ground. The scientists, the engineers try to figure out what the heck is going on. One, why is the failure there? And two, what are we going to do about it? Because now we have no way to steer the space station. So what happened was the guys on the space shuttle said, hey, we got a space shuttle up there right now. It's got rocket engines on it. Let's get after it. Let's figure out a way to make the space shuttle fly the space station on its back. And that's exactly what they did. Came up with a new set of commands for the space shuttle. So now the space shuttle knew how to fly with the space shuttle attached to its back. Of course, it wasn't nearly as accurate as what they had on space station. And what that meant was that they could only point the space station at the sun for a portion of the time, about half the time that it needed to fully recharge the solar rays, which basically meant that we had to shut down half of the power system in order to be able to conserve our resources. Half the lights were out. Half of the atmospheric revitalization system was out. CO2 levels started to rise. Things got to be kind of, uncomfortable. You're floating around, you got a headache. Things are just generally uncomfortable. But still, everybody had to focus on the mission at hand. Everybody had a job to do. As we work through it, eventually we find that the computer systems that had been designed, no one ever thought that this was going to happen, but there was a common port very close to the power supply that sucked air in as part of the revitalization system. And what happened was that that power supply actually had all 3 lines of the computers attached to it. Eventually had corroded and caused a short. Who knew? It took about 7 days before they figured it out, but through coordination with the ground as well as the on-orbit crew, we basically had the inside of the space station completely torn apart. We were thinking to ourselves, because we had just finished hanging these set of solar rays out on the end of the space station, that there was some static electricity that built up and fried the system. So we were chasing wires all over the space station, pulling equipment out, trying to figure out exactly what was going on. And ultimately, it was just this common power supply that had corroded, a relatively simple solution. We were about 48 hours away from evacuating the space station at the time because of all the failures that we were dealing with. But you get that responsibility, and you get into that zone. And that zone within NASA was that adherence to mission assurance. What does it mean to me? This is important for me to be able to do and execute my thing that I have to do within my organization right. Now, I have no influence on what everybody else does, but what I do have influence is on what I can do. And so the objectives that were given to me, the procedures that were given to me, the duty that was given to me is what I went out and what I executed.